Okay, we'll wrap this up, chapter 10. It's not the easiest one in the world, is it? But the final section we'll do is section 10.16, which is called impedance of a transformer. And we'll look at it and sort of utilize some of the things that we discussed in the um, per unit section, and we'll give this up. I'd like to finish it, but time is running out this semester, so we'll stop this at after this little section and work through example. So he tells us that the internal impedance of our transformer, uh, we determined that Z sub P here back in section 1012, and it's comprised of a resistive portion and an inductive portion. But we also, I think, mentioned that it was primarily, um, in terms of the impedance. But anyway, so that's how we defined it. The combination of those two things. Okay, so in power and distribution transformers, big transformers, its value is always indicated on the nameplate. So anytime we're looking at a nameplate on a transformer, we should see some type of indication of the nominal load impedance. Okay, so when that's given, thus if the nameplate is marked as 3.6%, the per unit value of that, would be this. Okay, so that is always going to be given to us. So we zip right up to this example, and it says a transformer is rated at 250 kVA, 4160 volts over 480. I think we use that combination again. That is a common transformer ratio, primary to secondary. It's a 60 hertz, and it says it has a base impedance that's equal to 5.1%. Calculate the base impedance on the primary and secondary side and the total internal impedance of the transformer referred to the primary side. Okay, and that's what this is all about. This is all developed and referred to the primary side. Okay, so as we begin this thing, all right, basic power equation, voltage squared divided by resistance. All right, that's our ELC 131 version of this thing. Now we've got to take it up a notch because we're not in that world anymore, and we've got to call this voltage on the primary divided by the Z, the impedance on the primary. Okay, and this is not active power. This is apparent power. So we want to make sure that we indicate that with the S sub N. I put numbers on this. My primary voltage as given here was 4160 squared divided by, oh, wait a minute, what did I not do? Oh, wait a minute. Well, I'm going to leave that in there. That's okay. I'm going to leave that in there. I'm going to put this here, and then I'm going to remember that this is given as 250 kVA, or 250,000. All right. So, here's our original equation. Here's the numbers. I solved this for ZMP, right? And so ZMP on this side, that on this side. So I end up with 4160 squared divided by 250,000. And I'm going to come up with 69 ohms is our ZMP. Okay. Base impedance on the secondary side. Similar calculation. We use the Z and S. The voltage on the secondary side is 480 volts. We square that. The total apparent is 250,000. And this number comes out to be 0.092 ohms. Okay. So the actual value on the primary side is the next question here. Find the total internal impedance of the transformer referred to the primary side. Okay, so if I try to work with that, and he says we're talking about the primary side, it has a an impedance, given on the nameplate of 5.1%. So Z sub P, this is going to be, in reference to the primary side, 5.1% of the 69 ohms. And we will find that that will be 3.52. Okay? And so just a little simple example of that. All right. So we'll wrap that up. There's some other good stuff in here. But we've got enough. We've got a good understanding of transformers, a pretty high level understanding of transformers. And we'll wrap that up there and say we're done.